This tutorial is about how to find voltage across each capacitor in the electric circuit. We'll be solving this example. The question is, find voltage across each capacitor in the circuit and calculate energy stored by 60 microfarad capacitor. So before we'll start, let's talk about main ideas we'll be using in this question. First of all, looking into the circuit, we can see that capacitors are connected differently. Some capacitors are connected in series and some capacitors are connected in parallel. So in order to find the equivalent capacitance, we need to just remember what would be the equation for capacitors in series and in parallel. It is easy to remember that we actually will be using the opposite equations, opposite to resistors. So that means that if we have two capacitors connected in series, the formula, the equation for equivalent capacitor will be C equivalent will be C1, C2 over C1 plus C2. And for capacitors in parallel, the equivalent capacitance will be the sum of all capacitance. And if you have only two, so it's going to be C1 plus C2. And the next idea is how to find the voltage across each capacitor if you have only two capacitors connected in series and they both sharing the same voltage, total voltage. So we're going to use the voltage divider, but this will be capacitive voltage divider. What's the difference? Let's say the voltage across one capacitor, the first capacitor, will be, you put the opposite on the top, C2 divided by the sum, C1 plus C2 multiplied by the total voltage. And similar for the second capacitor, so the voltage across second capacitor will be, in this case you have to put the first capacitance on the top divided by the sum C1 plus C2 and multiplied by the total voltage. So pretty much this is the all equations and the all theory we're going to use in this question. Now let's start solving the problem. So looking into the circuit, what we have only one voltage source, 60 volts, and this voltage source is like these 60 volts are shared between all these capacitors. Because there is only one power source, we can apply voltage divider. But for voltage divider, we should have only two capacitors connected in series. So we need to simplify this circuit to replace it by the circuit with two capacitors connected in series. So what do we have? We have two groups. This is the first group and this is the second group connected in series. So this is number 1 and this is number 2. 1 and 2. We have to simplify these groups and find equivalent capacitance for each group, and then we can replace it by the circuit from two capacitors connected in series. So let's do this. For group 1, the equivalent capacitors, C equivalent 1, will be, we have two capacitors, 50 and 70, connected in parallel. So if they're connected in parallel, to find the total or equivalent, we have to add them up. So 50 plus 70, we have 120. And then we go into the second group. What do we have here? We have 20 connected in parallel to these two, 60 and 120. So that means that equivalent capacitance for the second group will be 20 plus, and how to find equivalent from two capacitors connected in series? We do 60 times 120 over 60 plus 100. And the answer is 16 microfarads. So now once we found two equivalent capacitors, we can replace the original circuit by the circuit consisting of only two capacitors connected in series, and the total voltage is 60 volts. Because we have only two capacitors in series and only one voltage source, we can use capacitive voltage divider rule to find voltage across each capacitor. So for 120, V at 120 will be 60 over 120 plus 60 multiplied by the total voltage, and total voltage is 60 volts. For this, the answer will be 20. And the second voltage, the voltage across 60 capacitor will be, because the total voltage is 60 volts and we only have two elements, so the voltage across the second capacitor will be 60 minus 20, and it is 40 volts. Now let's check what we actually found. The voltage across 120 capacitor is the voltage across the first group, so this group, and this 20 volts is the voltage across these 2 points. So pretty much if you put the voltage source, that will be 20 across the group. And the second voltage, the voltage across 60 capacitor, is the voltage across the second group, all these groups, and that means that the voltage across these 2 points, 2 nodes, and that means that this voltage is 40. What does it mean? Looking into the first group, we have two capacitors, 50 and 70, connected in parallel, and they're in parallel to 20 volts. So that means that 20 volts is the voltage across 50 capacitor and the voltage across 70 capacitor. So pretty much we already found the voltage across two capacitors, and this is part of our answer. Voltage at 50 will be 20 volts, and voltage at 70 is 20 volts as well. Let's move to the second group, to this. The 40 volts is voltage across this point, and it is the voltage across 20. So that means that we actually have the third capacitor known, the voltage across third capacitor known. So voltage across 20 is 40 volts. So pretty much half of the question already answered. We only have two capacitors left. This is 60 and 120, and this 40 volts is shared between these two capacitors connected in series. So what we can do in this case, if we just take these two capacitors by its own, connected in series and having the total voltage of 40 volts, we can go to this simple circuit with only two capacitors connected in series, and pretty much doing the same thing as we did before. By using capacitive voltage divider rule, we can find the voltage across each capacitor. So let's do this. The voltage at 60 will be taking the opposite on the top, 120, divided by the sum of two capacitors, 120 plus 60, multiplied by the total voltage, and total voltage is 40, and the answer will be 26.7 volts. Now it is pretty easy to find the voltage across the second capacitor, 120, because the total voltage is 40, so we subtract the voltage across the first one, 26.7, which gives us 13.3 volts. So let's see what we've done. We found the voltage across 50 capacitor, the voltage across 70 capacitor, the voltage across 20, so this one, and we also found the voltage across 60, here we go, and the voltage across the last capacitor, 120, so this is the answer. Now we only have the last part of the question left. So the question was to calculate the energy stored in 60 microfarad capacitor. So in this capacitor. To find the energy, we need to use the formula for energy, which says that W equals half C V squared. And we pretty much already know the voltage, so just substituting the numbers give us half multiplied by capacitance. C is capacitance, what is C is 60. But the capacitance is given in microfarads, so we have to convert it to farads. Micro means 10 to the negative 6, so we multiply it by 60 times 10 to the negative 6, and then multiplied by V squared. And what is V for 60 volts? It is 26.7. So times 26.7 squared, and the answer will be 21.4 times 10 to the negative 6 joules.